No cron jobs, no off-chain scripts. Let's schedule a smart contract call without leaving the Hedera network. Before we get into the code, I'm just going to give a quick overview as to what we're going to be covering. We're going to be covering the new Hedera improvement proposal number 423, which essentially allows you to schedule a smart contract call and many other transactions on the Hedera network for a time period up until 2 months in the future. This is a big upgrade from the previous version, which was only 30 minutes, and it was limited to only a few transactions. Now you can do any sort of smart contract interaction. Anyway, with that said, let's jump into the code. So I've got a really basic smart contract here. It's just your typical lock smart contract. And essentially what it does is when the contract is deployed, it's got a payable constructor. The deployer of the smart contracts will pay any amount of HBAR. It will specify the unlock time, and then that amount of HBAR will be locked in the smart contract until that unlock time has expired. Then you can call this withdraw function, which withdraws it. So that's a really quick overview as to the actual smart contract. And let's have a look at this incomplete test script which I've built, which we're going to be coding together. So I've got a few tests in place already. First one obviously deploys the smart contract, and then it just makes sure that the owner is the person it says, some basic robustness checks, and then it checks that the balance is locked. It then tries to withdraw the HBAR inside of it. Because the smart contract won't have expired yet, we would expect this to fail and to be reverted with "you cannot withdraw." And then what we're going to be doing is we're going to create the test which schedules the transaction so that the transaction executes after the expiry date. We're going to schedule it now. The smart contract will actually execute itself on the Hedera network when we specify it. So we'll get into that. I also just want to quickly specify at the top here. So we've set the smart contract lock expiry time to be in 1 minute. Now, this is a really important point. When it comes to the EVM, everything is done in a Unix timestamp. So it's done in seconds since 1972 or whatever. With the EVM, it's done in seconds. With the Hedera scheduling service, it's done in milliseconds. So you need to multiply your timestamp by 1,000, essentially. That's a really important note. You don't want to be using the same number for your smart contract constructor, the expiry in your smart contract constructor, and the scheduled transaction execution function. Let's get into the code then. So first thing that we need to do is we just need to create a normal contract execute transaction. This is just like you would do usually, but except we're not going to execute it yet. So let's do that. We're going to build the contract execute transaction. I've got my AI, which is recommending it all. Thank you very much. And it's also jumped the gun a bit. So, well, we've got it here. Let's describe it, describe what we're doing. So the first thing that we're doing is we're creating this contract execute transaction object. So that's obviously the contract execute transaction class. We're saying we want to call the withdraw function. We've specified the contract ID, and also we're setting the gas as well. This is just an arbitrary number. You could maybe make it more optimized by checking how much gas it would take. Then the important thing is we are going to be scheduling, creating a scheduled transaction. So here we're importing the schedule create transaction class, creating our scheduled transaction object. We're specifying the transaction which we want to schedule. So in that case, it's our contract execute transaction, which we've created just above. And we're also setting the expiration time. So for the expiration time, we need to use the timestamp class from the Hedera SDK, and we're specifying the from date method. So this is a static method. And we're also saying, okay, we need to then construct a date from our Unix timestamp right at the top, which is 2 minutes. So given our smart contract is going to take 1 minute to expire, our scheduled transaction is going to occur in 2 minutes, which is after the 1 minute. So we'd expect it to go through successfully. There's also another important parameter which is being set here, which is the set wait for expiry, and we're setting that equal to true. Now, if you set this equal to false, essentially what will happen is as soon as you have all of the relevant signatures on a transaction, on a scheduled transaction, if all of the necessary signatures are there, it would execute. Meaning, with this example, it would theoretically execute before the 2-minute deadline. In some use cases, this is useful. In our use case, we want to make sure that we wait for the expiry date. There is just one thing which I want to mention here, which is we're going to execute and submit this we're going to execute this schedule create transaction using our client account. And that client account is also the same account which needs to sign the contract execute transaction. So we don't need to do extra signatures because we're already sort of wrapping up the transaction with our signature. However, there are of course instances where your signer isn't going to be able to sign the transaction then and there. And this is the whole point of the scheduled transaction. It's that you can have someone else sign the transaction. So I really just want to quickly show the documentation for how you can do that. And we have a schedule signed transaction class where you use the schedule ID. The schedule ID is, you can find that from the scheduled transaction after we have submitted it to the network. So of course, you can only call this schedule signed transaction after the actual scheduled transaction has been submitted. And from this point, you then want to sign it with the relevant key. And you can do this multiple times. If you've got a transaction which requires 5 signatures, you can sign it 5 transactions over the course of 1, 2, 3, 4 weeks. Just wanted to get that in there so that it's known that if you want to have other people signing a transaction at a future date, that is the relevant API that you use. Final thing that we're going to want to do is we're just going to execute this transaction. So let's go execute transaction, cool. And then we're going to get the receipt and we're going to make sure that the receipt is equal to success. And again, just to quickly reiterate, we don't need to sign this particular schedule create transaction with any other accounts because we are executing with the client. That's putting our relevant private key on the transaction. That same private key is the owner, is the one who is able to call the withdraw function. Okay, let's now run this test. And what we'll need to do as well is we're going to then need to obviously test it, but then we're going to need to check the mirror node, check HashScan to make sure that the transaction is actually executing in 2 minutes time. So let's run this test, npx hard hat test. Awesome. So all of our preliminary tests have gone through fine. And then it says that it successfully scheduled the smart contract execution for the future. So what we can do is we can head over to HashScan. And as we can see, we've got this recent smart contract interaction. So we've got our Ethereum transaction over here. And this has created the smart contract. That's the smart contract which we deployed. We should also see a balance of 1 HBAR being transferred. Yep, so that's the 1 HBAR that we're locking up. And then we have this schedule create transaction. So this is the schedule create transaction which we executed over here, which is saying, look, I've got this execute smart contract transaction, which I want you to execute in 2 minutes time. And it's probably been around 2 minutes. We'll wait for it. And there we have it. Contract call about 2 minutes afterwards. And this contract call, we are, if I refresh to get a bit more information. Yeah, there we go. We're calling the withdraw function. And as you can see, the result is the smart contract is returning that 1 HBAR to my account, minus the small fees. So there we have it. That's how we can use the Hedera schedule service to schedule things like smart contract calls to execute in the future. But also, I really want you to remember this, and we can do more demonstrations in the future, that actually you can schedule it in the future, but also within that time period of it executing, you can get relevant people to take that scheduled transaction from the network and sign it with their own key as well. If you like this video, give it a like, give us a follow, repost it, and don't forget to share it with all your friends, try Hedera, and give me any comments if you've got any feedback below. Thanks a lot.